Hello and good evening, everyone. All right, let's get started. Huh, we are just about right on time. I meant to start the stream at 8 p.m. just like yesterday. So yesterday we started the stream and then hit a bottleneck or a hiccup regarding the display. Showing the display output from Vicharak, the SBC was becoming a little bit of an issue. Sorry. So we packed it up for yesterday and we started today. Stream. I'll turn on the camera and yeah, I have also another view today. Would you look at that? So this is the one that you will be able to see everything that is on my desk, and this camera, that's the one, is my face cam. I am just looking into if my audio level and everything else is in the right volume, right settings. Just give me a little while and let me know if there is any issue that you can see on the stream side on the other end, and I will make sure to make it go away. Right. I will be monitoring the streams on this. Right. Let me try and yep, it works. Cool. Right. So we have our Vicharak board. I have powered it on, and for the most part, it is exactly as it was yesterday. Right? There has been no change from my side that I have implemented on the software side. It's just booted and oh, right. It's just booted and it's in the stock settings. My face cam has a 100 millisecond kind of lag. Let me see if this is something that can be fixed. I'm not sure. I'll let it be. Let me know if it's too annoying. I will try to reset it, but other than that, I'm letting it be. Most of the time, I'll be spending my time on this keyboard and this mouse, which is connected to the SBC, which we will use to interface with the Vicharak SBC. All right. Anybody in the chat? Hey, Shashwat. Nice to see you again, man. Hello and welcome. Is the audio and everything all right? I was given feedback yesterday that my audio level was a little too low. So if you feel like the audio level is okay, let me know. Or if it's way too high, also let me know. All right, everything's fine. Let's go. So displays, I got the display up. So first of all, the challenge in order to debug what was going wrong, I found that the issue is not with the board or with the system, basically say the Linux or OS X or anything as such. The issue seems to be with USB protocol itself, where if you connect multiple camera or like any kind of what is called from USB USB class perspective, USB video class or UVC for short. So if there are multiple UVC devices on the same USB bus, it tends to just take the first one and ignores all the latter ones, right? So it was not an issue with the system, the host system. It was not an issue with the Vicharak SBC. It was not the issue with the cable or the adapter or the capture card. So all those things were fine. I just needed to connect the capture card to a different USB port, which is what I did not have in my this is M1 Mac, and this has only two USB ports, so they were taken up with other inputs. So I didn't have enough inputs. So I'm going back to using my Linux notebook, which is the 2018 Dell XPS 13, right? Just in case. Um, so that one has three USB-C ports, which barely is sufficient to get all the inputs in. One of the inputs is for the display capture. I'm capturing the SBC's desktop, as you can see right now, where I can move the mouse and everything. And the other one is my face scan, the one that you can see my face on, and the other one is the shoulder cam that I'm showing this desktop situation. This is a little bit messy, and I understand like not a lot can be seen over here at this moment. I'm just starting up my streaming and everything set up to be like starting from scratch. So I'll gradually figure those things out and gradually make those things better. For the time being, this is the view I got, right? So if I have to show something, I'll probably bring it close up and show it like this, or show it in front of me and show it like this. Other than that, this is the overall views that you have got. Most of the things that we'll be doing today will be on, let's say, terminal, right? Uh, so Vicharak comes with Mate desktop. So Mate, I'm not very comfortable with Mate, but I'm fine with it. It's pretty like easy on the resources, so I understand the choice. This is good. So yeah, this is it. One question that I have is the text size okay on the terminal, or should I increase the text size? Because I understand that this is actually 1:1. If you're watching it on a HD monitor and full screening this page, you should be able to see 1:1 display. There might be some little bit of compromise on the display because of the encoding from the OBS and de-encoding on the YouTube side. But other than that, it should be pretty much scaling wise 1:1. So if the size is fine, I'm going ahead with it. If it's not, let me know. I'll increase the size, font size from the preferences. For me, this is fine because I get to see more lines in particular sections. So this is good for me. I might actually want to increase the width because that gives me a little bit more working area, I think. Right? All right. So first of all, let's do an apt update. Maybe. Oh, okay, yeah. So, by the way, here are a couple of things. I went ahead and found out, even though I didn't try it yet, but I found out that I didn't need any username and password to put into log into the system. It automatically logs into the desktop. But the default user account, that is Vicharak, which is same as the host name. But anyways, would have been Axon at Vicharak. Anyways, point is, the username is Vicharak and the password is 12345. The number 12345. That's it. It's pretty simple, and you only need it if the screen locks up. Usually, like that's when you need it. Other than that, you don't need it, because even if you want to go to become a super user, you can just say sudo su, and you will be super user. You are root. Yeah, so you are a root user now. So everything is well and good on that front. These things are not very obvious or well documented upfront. You have to really dig in and look into the depth of the documentation to find these things out. I think there should be a quick start that gets people those very specific information upfront, or there should be some kind of a card or something that comes with the board, which says that after opening the board, do this. Like basically attach the Wi-Fi antenna, make sure that the power whatever the power brick that you're using has this feature, and I'll come back to that. There's a lot to say about that thing. And or there are whatever the other things, like this is the username password that you might need, etc., etc. And also the configuration, as in the app for configuration management, right? Which is a fork of Raspberry config, if I understand correctly, which is called Vicharak config. I think Vicharak config, yeah, Vicharak config. So I haven't tried any of those things yet. I kept it as stock as possible. Only thing that I have changed before starting the stream is to change the power management and set there that so that the screen doesn't go off if I don't touch it for 30 minutes. That was the only thing that I changed. Other than that, everything is fine. So let's first start with apt update, which should not make any changes. It will just get the repositories updated. I am not going to run upgrade immediately because if there is something that breaks the installation, it will be really hard for us to get the OS back online. So I'm trying to get as much testing done as possible with the baseline, like whatever the stock OS is there, with whatever the stock heatsink is there, and everything connected as it is. So I'm thinking that first we go ahead and check out the system specs, right? Let's see what happens. Low system hardware info. Hmm. I wonder what Mate does for, because there's system monitor which shows all the 8 CPU cores. That's good. Can we full screen it? All right, that gives a pretty good graph of the CPU usages, which is pretty, like it's idling 10%, less than 10% for all of those. I think all the big cores are sleeping, small cores are raving. And the memory usage is also really, really low. Like basically that means we can get a lot done here. Okay, should we install NeoFetch? Okay, apparently it was already installed. So right, NeoFetch shows that we are running Ubuntu 22.04, which is the last LTS that they built this on. I think, if I'm not mistaken, but don't quote me on this, they have started working on the latter LTSs. Again, I don't know uh, anything about it, but I'd hope they would do that. So this is the previous LTS. If everything goes right, if all my tests that I have planned out for this, if all those benchmarks go right, if I have gotten all the data I need, then I will try to upgrade this to like distro upgrade it to 24, like latest LTS, and see if that works. So fingers crossed for that. Let's go at it one step at a time, right? Let me see what are the things that I have planned for this. Right. Right. So first of all, the power, right? One thing that I said that I will come back to, and I did try yesterday one more thing about the power delivery mechanism, that is looking into how much reliant it is on 12-volt power, like the power distribution, USB power delivery spec to get 12-volt input in order to function. And so what happened is that I was checking the bus, so basically the power delivery, like the PMICs, like the capacitor output capacitors of the PMIC, and I was seeing that all the uh, capacitors were at 5.1 volt. I was like, why? And then I checked the pin 1 of the GPIO, which is supposed to be the 12-volt pin. By the way, let me bring it out. Like, what browser do you have? Chrome, right? We saw that Chrome yesterday. Yeah, we have Chrome. So let's open up Chrome. Let's visit Vicharak.in. No, wait. Docs.vicharak.in, right? Okay. And oh yeah, let me turn off my face cams for the time being. So what I'm talking about is Axon's documentation. Oh, what is it behind? Oh no, the documentation is behind the authentication gateway now. That's bad. It was not like this even in the morning. Last I checked. All right, we can still go to directory listing, and if you see the GPIO description, so you can see the pinouts from here, I suppose, right? Yeah, so we can see that the okay, let me zoom in a little bit. Uh-oh. Yeah. All right. So as you can see, the first pin, the pin one. So by the way, this is how I tried to get into more documentation than what is available on the surface level, because this is not something that you can come to from generally following the links. So I was digging around in the documentation to find out what are the other things that you can find, and this is something that I found out. The 30 pin GPIO that I said, uh, this is the pin out for this, for anybody who is looking into it. Pin 1 is 12 volt power, and pin 3 and 7, sorry, 5 and 7 are 5 volt, and pin 3 is ground. So those are the ones that I actually needed. Rest of the GPIO is mostly for like driving words, and probably you can also run some PWM, some SPI and I2C. And there's also power for, like, you can get 1.8 volt or 3.3 volt for driving some kind of a small power logic ICs. So that's pretty good. That's actually really good. I appreciate that. 3.3 is sometimes available, 1.8 is not, and you need some kind of LDO or something to basically break it out, and that is not convenient. So having from 12 volt to 1.8 volt all the standard power rails available here on this 30 pin GPIO, that's actually fantastic. Like I like that. I love that. There are 4 pin SADAs. Yes, it's like serializer and ADC. I don't really know what's the utility of this yet. I'm not as proficient on this. Probably I should do some more read up, and probably there is more to read up. I just don't know them yet. Anyways, so now that you know where to go to find out this documentation, maybe you can tell me what I need to know about this. Right. So I was poking around and saw that 5 volt rails were having 5 volt, but 12 volt rail was also having 5 volt. And I was a little bit confused, like, why is that the case? So I asked, and in the community, and I was told that because it was not finding 12 volt, it failed to like, it has fallen back to using 5, sorry, it was not finding 12 volt, so it has fallen back to using 5 volt to power itself up and boot up and work. So my uh, takeaway from that was the board actually works just fine. Like, this is not official stand. Akshar said on that, Akshar is the CEO of Vicharak, said that it is actually not like, there might be some limitations, but without knowing those limitations, as a user, if it walks like a duck, if it quacks like a duck, if it talks like a duck, then it is a duck. So if it works for me, if I can run sysbench, and if I can run like neofetch and most of the generalized programs, you can run system monitors and stuff, and everything seems to work. If I put the CPU load and gives me the results that it's the max CPU capacity it should be giving, and it is giving that kind of data within the run variance, then it is working fine for me. I don't know what exactly would be not working properly. I don't know those domains. um, I will have to go and figure out those things out, because I'm still like, even though I have power bricks that will be able to provide PD with 12 volt, I am still running it on 5 volt, and my understanding is this should do just fine. If it doesn't, I will notice which parts of it that doesn't do fine, right? So on this note, I should point out, maybe I should get the camera closer like this. This is a bit risky, but let me try it out anyway. If you can see here on the, can you see, is it visible? Yeah, it is visible now. So the power it is sipping is 5.1 volt at 0.5 amps. So that is barely 2.5 watts. That is super power efficient. So I'm running that, whatever you're seeing on the screen, that is running with that much of power. That's just 2.5 watts, right? So I did a complete reset. So let me do that. Let me try and do that, and I will also try to show you the power usage there, and you'll be able to see exactly how much power it takes for the boot up, the startup process. Curiously, that's the only time when it takes the most amount of power. For some reason, booting up is when it's consuming the, like, peaking at the maximum power, which you will see. But even when I'm running all the sysbench and everything, and it is giving the result it should be giving, RK3588 should be giving, and it's at max threads, it's still not going above that. So boot up is the only time when it's taking the most amount of power. It doesn't have any peripherals attached, and it's still working fine even at that time with 5 volt normal generic USB power delivery is working fine. 5 volt power USB power is working just fine. So that's my point. Let me demonstrate that by trying to reboot this system. I will just quickly go through the NeoFHS details. That says that the system is up for 1 hour 24 minutes. I had started it up a little while ago before starting the stream. All the other details that you have been seeing so far. It has 8 GB of RAM, of which less than 1 GB is being used. So not even 10% utilized practically. Right. So with that said, let's reboot the system, right? Now you should be able to see the display because I'm capturing the display like this. Now, if you notice here, the power goes 1.1 amp, 0.7, 0.8. It will peak a little bit higher at 1.6, right? And that's it. That 1.6 amps is the highest I could got it to go, 1.5, 1.6 during boot time. So if you have a 2 amps power brick, USB power, that will do just fine. That will not be limiting the hardware. This is, again, this is from what I understand for the time being, running the things that I have run so far. There might be challenges that we will face. Let's figure those things out. So far I haven't faced any of those things. Now, so we have rebooted. The reboot takes whatever the time it takes. I will measure the frames afterwards when the stream is over, and come to the conclusion exactly how many seconds it takes. I did not see any kind of lag apart from the first time we booted up, at which time it took a little longer. So let's open up. Okay, never mind. Terminal. Yeah. Let's open up the terminal and try to see the boot up time, how does the system sees it. So let's just, oh, okay, wait, let's become super user, um, system d and analyze. So it says that it says 15 seconds to boot, and so graphical target reached after 2.33 seconds in user space. It's pretty fast. Like for an SBC, this would be good. If my Jetson Nano took this much time, I'd be pretty happy. I would not need to create a new distro for that, right? So all things said and done, this is pretty good. Um, Now, let's see what is actually taking it so long. So USB device service, whatever that might be, that is actually blocking it for the longest, blocking the boot time for the longest. Other than that, it's actually super lean. Even the blue man is usually, that's the that's one of the main culprits. Blue man, Snapd, Network D, yeah. Even they are not holding it back much in the milliseconds range. None of them are coming close to a second. So whatever is that USB device service trying to do, maybe it's trying to negotiate the device or host or whatever that is. I don't know. I'm just like gaze. This is all guesswork. I don't know exactly what's happening, but it's taking the longest. It's taking 10 seconds, right? Apart from that, everything else seems super lean, and I love it. This is pretty fast. Okay, how about we run some lsblk and see how does it see its mmc. All right, so it has provision for CRAM, but the mmc is partitioned into so many smaller partitions because, of course, there are probably AB partitioning. I'm not sure if there's AB partitioning, but it might be. The mmcblk 3 and 4 seems like this can be the boot partitions for, like, they're kind of mirrored boot partition. One boots, oh yeah, yeah, so this is the first one. This is the partition A. So if you apply, for example, any updates, it will be applied on the other one, and then it will be marked as the next boot partition. So if you want to know more about AB partitioning scheme, which also, by the way, Steam Deck also uses that, even though it's x86, it uses that because it's nothing to do with ARM or Android or anything else as such. But Android forums have pretty good documentation around, and they are the ones to come up with this, because they had the highest rate of failure, breaking the devices, etc. So they came up with this mechanism where a running live system does not try to update itself its own boot partition. It tries to boot the B partition and then mark that as the next boot partition. So whenever next time boot up, that one you boot up from the other one, and the previous one gets marked as to be updated. And you, so basically in that way you always know at least one bootable, bootable boot partition, bootfs is there on your system, right? Which is actually pretty good, like pretty smart. Now this user data, I see that is 256M, and slash is 28G. So user data, I'm not sure what's happening, what's going on in there. Maybe let's open up the file system and see what's going on in there, right? Sorry. All right. How do I go to other locations? Places, tree, file system. Right. In the file system, we don't need to go to boot for, at least for the time being. Let's check out this user data. What does it have? It actually has probably some test details. Let's explore that. Configuration for Vicharak power management tool. Conservative on-demand user space power, interactive performance. All right, where do I add this? Do I have any config.txt like Raspberry Pi? Maybe. we can try these things out, but I don't want to try those things out immediately. I'm just exploring the system just with you guys. So let's take one step at a time. So it's good that you noticed. This is something over here, piano cool edit.mp3. I'll close this for now. Can I play it? It will check another thing. So basically we can see that whether it has the codec or not. Um, Whatever played, it stopped. I don't know whether you guys got any sound out of that. I didn't get any sound of that out of that, but I'm hoping that you might have. um, 200 frames count, H.264. So this is a template as in sample video, I'm guessing, and this is a PNG file for color calibration or resolution calibration. This is actually really helpful. I actually want to keep these files. It might help me with testing other boards and stuff. This is good. This is some. These are the things I love about engineering samples and stuff. Sometimes you get that from there. Now this is a production unit, but still, I appreciate that there are some of those utilities that are there. This is Mali GPU driver. Do I have to do anything about it? Huh. This is for x86. No, sorry. This is for ARM64. I don't know what's happening in here. I don't have any information around needing to use this, so I am not going to use this for the time being. Let's move on. This partition is 256 GB. Sorry, 256 MB, and right. Let's try DFH. It should work. Okay, so slash user data used only 8 MB of that 256 MB. Other than that is free. And have it, like, was it able to expand the root partition? Yeah, it was able to expand the root partition, because I remember, if I remember correctly, the first time I booted, I kind of got confused because the LED was not blinking correctly. So I kind of got confused and shut it down and rebooted it back again. So I was a little bit afraid that whether it got to run through all the scripts that it needed to run through, but apparently it did. Right. Hopefully it did. Cool. Awesome. So we are done with the startup power. What should we run next? We should just check the thermals, right? We already checked the resource monitor. So should we? What kind of resource monitor should we use? Should I just keep the resource monitor in the back side, make it transparent or something? Or should I add some widgets? I would like to add some thermal widgets in over here. Let me try and find out if there is thermal jet for Ubuntu. Oh, I think this is not around about something else. This is just about the user's keychain. Don't restore. All right. Glances. Right. How does glances work? This is too involved. Do we need that? Maybe not. LM sensors is probably better. Right. Let's get LM sensors and start with that. Let's install. Right. Let's install apt install um, lm sensors sys sysbench, and what else? I'll figure out. iperf, I think also need iperf, right? Oh, okay. mm, iperf 3. All right, cool. Now I have iperf and everything else. Let's first of all, let's try and see the Wi-Fi speed, right? Like we haven't tested that part. Let's see how Wi-Fi speed is working. I'm not gonna do anything crazy here. I'm just gonna try fast.com. It works well. By the way, this frames might drop because it's gonna try to choke my bandwidth. It's doing its darnest with these teeny tiny flimsy antennas. So 150 Mbps is more than fine for this. Fair enough. There is no objective Wi-Fi test, so I'm gonna move on from there, right? Let's keep it at that. We also would need HD perm. Do we have HD perm? Yeah, we do have HD perm. All right, cool. I we will come back to it. Okay, sensors. We can see the temp. Should we? Let's see if my root directory has anything. Okay, let's create benchmark. Let's create a directory and push everything there. Right, now let's run sensors again and get its output to temp 837. I'll just put the timestamp like this just because .txt. All right, instead of temp, let's call it sensor, so it's I know exactly how I got it in case I end up running different benchmark tools as well. All right, it doesn't matter, but let's do that. So now temperature is pretty well within tolerable range. That's the like very crazy thing about this board, is that I was not convinced if the those flimsy heat sinks were sufficient for running the board, but turns out it is. Like basically the board seeps power. It's so power efficient. The SoC is really good, so I don't really need to apply a bigger heatsink. Maybe a better dissipation mechanism. I was thinking like in a latter video or in latter stage I want to DIY home lab solution out of this, and at that point I probably want to use just a like copper slab or some kind of a metallic slab on the other end which has a good contact with the SoC. That probably should be sufficient if that slab is big enough, large enough. I'm definitely gonna give it a try and see how it goes, right? So other than that, the temperature is 43, like less than 45 degrees centigrade, which is insane. This is great. The ambient temperature is like 25 here, so 20 degrees, within 20 degrees of ambient temperature. This is great. This is workable. But now, what if, by the way, let me just move these files to, I don't like that. I don't like that funky character over there doing funny business. So I'll just change that file name. All right. So yeah, now let's run sysbench, right? I already ran sysbench once. I lied. I ran sysbench once yesterday just to know that how much it performs. So while I was doing power profiling, I ran sysbench. So let's see. Let's run sysbench. Yeah, let's run it with all 8 threads. So if I run sysbench with all 8 threads, and then I'll immediately run sensors as well once it's done, so that we know the temperature. What's the temperature time now? 41. Let's go. So now that we have, we'll come back to the benchmark. Let's first see the temperature. So after we have been through, like, we put the system to the stress test where it was drawing still 1 amp. By the way, I noticed it was just drawing 1 amp, not a 1.6 amp like the boot time. While all 8 cores were busy, it still did not go even 1 degree above where it actually was. Isn't this crazy? The critical temperature is 115. I am not sure anything is gonna make it reach that temperature. um, I'm humbled. I was wrong to doubt it. It actually does not reach even 45 degrees centigrade. That's crazy. That's awesome. I love it. Now let's go and see that RK 3588 total number of events. This total time is 10 seconds, which is perfectly valid. Perfectly valid benchmark numbers for, like, even numbers, even count for 3588, all 8 cores. If you have any doubt, go verify that with on any kind of, like, benchmark site where they have published any kind of data on maybe rock 5 or something, some other SoC. You will see that, like, 13 to 14,000 is where it lands. So this is absolutely on par with that. I'm absolutely fine with that. So one point to make here, this is to prove that power, providing 5-volt power with sufficient current does not hamper at least the CPU's performance to compute. Now this is not all the, like, benchmarks we will run. Let's see. Llama 3.2 test, Olama model 3.2. Can you post me some links? Where should I go to find the, as in get those things downloaded? Because I'm in a different environment, right? I would not be able to look into all those things. So I was planning to just run Geekbench AI, which tests not only, like, any generic model. It actually goes through, like, single single precision, half precision, like 32-bit, 16-bit, and 8-bit precision benchmarking. It does. So I have it planned. I will run it. All the application level, like, for example, running um, actual models and stuff. For those, I was planning to do another stream when I have the peripherals, because I need the camera. The particular, this board has different connector than my Raspberry Pi's connectors, so I cannot really use my Raspberry Pi's connectors here, right? So I need adapters for this. I am trying to get a hold of the connectors. I don't know how it will go, but if I get it within a reasonable amount of time, I want to do a full-fledged run of, like, running Olama with different open source model from Mixtral, Llama 7B if possible. And so all those things I do want to run. Not only LLMs, I also want to run some vision model and stuff. So all of those are on the roadmap, but they need some more other things, other supporting material in order for us to work. So yeah, Olama. Okay, so we are talking about essentially the same thing. So yeah, I intend to run it. I don't think I'm gonna run it today though, because it will be a half. I'm gonna give it a try because of your request. I'm gonna give it a try after we have gone through all the other benchmarks, and then I will give this a try. And depending on how it goes, then after that I will try to upgrade it to 24.04. Right? Let's go for it. Cool. So all the application check, those will be like for NAS, checking how NAS works, like all the peripherals like SATA connectors, etc. How the cameras work for using it as a um, frigate in VR, or for other those kind of use cases, the advertised use cases. I actually want to go through all those use cases, and that I want to set aside for some other day. Today I'm just mostly focusing on getting all the benchmark results out. Okay, so sysbench is done. I forgot the command for hdperm, so let's see. um, hdperm command. I can just do this and it will, oh yeah, exactly, that's why. So I cannot really get it from there. It has documentation chunked out because of its minimal size. So right, what should I use? Options and devices. What are the options do I need for running a benchmark? I'm not sure. Let me see some examples. Right, I think this is for info, for all the options. Okay, test hard drive speed, that's dash T, right? Okay, right, let's do that. What am I doing? Let's see. I am fine with operating on the, it doesn't matter, let's do that mmcblk 0p8. Okay, test dev mmcblk 0 partition 8. Okay, timing buffered read. So what if I do unbuffered? 304, that's insane. That's good for eMMC. That's actually really fast eMMC. That's good. Usually like 100 plus is where I draw that line. If it's lower than 100, this is not really good. If it's higher than 200, then I'm like, nice. If it's higher than 300, then that is fantastic for an eMMC. But this was a buffered, so let's try unbuffered. No, we should also try write test, right? Um, which utility should we use for write testing? Let's look up. Linux. Yeah, we can try DD, definitely. Very easy way to screw up the device, as in your installation, but it works. All right. So let's try this. All right. Um, 1G count 1. This is 1G count 1. Okay. Not TMP. Just write it here. I write it in my user directory. I don't care. I do care. Right, let's see how it goes. I should have probably enabled the progress flag, but even then, let's see. All right, it is 100 mbps write speed. So write speed is on par with, yeah, like the pretty normal, but the read speed is really fast. All right, acceptable. Let me uh, put this. Let me put both of this actually. To be honest, let's put. Let me delete this first. Rm test image. Right, now let's go back to hdparm and do that hdparm 0851 dot txt. All right, let's check out. Okay, we have that, and also let's try this out. Output of this, let's take it to dd 0852.txt. Okay, right, it's gonna take a little while. All right, did it though? Less dd. Oh no. Okay, at least the file is there. I'll just manually put it there. Is Vim there? Oh yeah, okay. Oh, never mind. All right, so now we have the read and write speed in the bag. All right, what else do we need to run? I wanted to run Geekbench. Let's go to Geekbench website and download Geekbench. Geekbench 6. Should we run 6 or 5? Let's run the latest one. Linux Ubuntu. Okay, we're downloading Geekbench. While it's downloading, let's also try Geekbench AI. I want to try the Geekbench AI. Let's see how it does. Yep, Geekbench AI. So as you can see, Geekbench AI actually does the full precision, half precision, and half precision is 16-bit, and quantized, that is 8-bit. So this is the one, if the claim is correct, of 6 stops on int 8. So this result, the third result, the quantized result, would be significantly higher than the other two. So let's try, and let's go ahead and download this. I'm actually more interested in running this than the other one. normal Geekbench 6, because normal Geekbench 6 result for RK3588, you will find it anywhere, everywhere. But this one is not yet available, that I can see widely available with a like consistent result. So I want to try this out. This is very new. This is downloading almost a GB. All right, while this is downloading, let us go ahead and yeah, put it aside. Let's go to downloads and see which one. Yep, this is the one that already got downloaded. Let's extract. Huh. Right. I will let it finish. I'll let the other download finish, then I will run the benchmarks. I'm hoping, by the way, I don't think I need to run those benchmark as root user. So all right, these are already executable, so I can just go ahead and run Geekbench 6. I will. Let the AI Geekbench download finish, and then we'll go ahead and run them one at a time. All right. Is there anybody else in chat? No, Sashwat is the only one. Hey Sashwat, hope you're still watching, dude. Yeah, I don't know whether he got disheartened by hearing that I will not run Ulama today. I will give it a try, but it was not my plan for today. But I definitely would run it. Would try it out. It's not that I'm gonna miss it. It's just that it was not planned for today. If after everything I still have time, I'm definitely gonna give it a try. Thanks, man. All right. While we are waiting, are you in any way working for Vicharak or with Vicharak? Like, I'm just trying to measure your interest. How, why are you? What interests you about this Axon board? Um, I'm not seeing a lot of buzz in YouTube or any other places. But I definitely think this is one of those landmark moments that we should probably be looking back and remembering. So yeah, I'm pretty excited. I'm not seeing that much excitement anywhere else. So just trying to understand, like, how are you seeing this release, and do you have yours with you, or have you ordered, or have you planning to? The download is almost finished. Let it cook. You're just interested in SBC. Yeah, me too. Like, I'm really interested in SBCs. I have plenty. So while it's downloading, let me just give a quick rundown, right? So I am so far behind testing all my SBCs. So I had been mostly working with Jetson Nano and Raspberry Pis. I have Raspberry Pi multiple versions. Yeah. Um, I have some videos that I uploaded about Raspberry Pis, camera and NAS and all the other stuff. You have Zima board. I actually want a Zima board. I really love the kind of form factor, the concepts that they started working with. You have to try Axon. You should. Really nice device. Like, there are things that can be better in one way or the other. Mostly documentation. Now that I'm realizing most of the design choices that they have made, those are actually not bad design choices. Those are pretty good. The only thing that I'm lacking is that, okay, the communication could have been a little different. Uh, what if it was much easier to for me to understand? The marketing page is really good, but the documentation page needs to be a little bit better. Zima board I do want to try. I do want to try out a Zima board. I didn't get my hands on it, and by the time I got my hands on it, it was the price was inflated really bad. So I was like, no, this is not my time. I will come back to it. So right now I am working with a couple of, as in working on. This is these are some Latte Panda boards. Like this is the dev board of Latte Panda Mu. This is the light board. These are the fans, heat sinks, and this is the Latte Panda Mu that I am actually very interested about right now. This is x86 board. It's a little bit different than our run-of-the-mill ARM or RISC-V SBCs. But one of the good things about x86 is that entire issue around image build and specific downloading specific image, building and downloading specific image for that particular board, or so that's not really a problem. You can just download any Ubuntu image or Fedora image or something like that, and you can run it. So this is what Latte Panda Mu looks like. I'm super interested about this. This is a module form factor. This is like a DDR2 module, if I'm not mistaken. So you put that on a carrier board, and then you fan out the IO whichever way you want. And there are really nice use cases around it. And I was specifically very much interested about that for quite a while now, last couple of months. Uh, and there's also I have the Coral TPU module, the SOM, along with, so basically the dev board as well, and all, and the, what is the name of that other thing? This five Vision 5 2, right? So those are the ones I really need to find some time and try Intel N100. So this is Intel N100. This one is Intel N100. Um, I have my home lab set up with only SBC. Yeah, you could say me too, pretty much. So that corner you're seeing, this is the NAS, my regular NAS, and this is the like a more higher end NAS. But all of them, like one is Raspberry Pi, the other one is N100. These are sorry, not N100, the N5105, the previous one. This was with Asustor. So that's the one. So but most of these are like small single board computer form factor. I love this form factor. I am really in favor of like completely like one big giant data center where everything runs inefficiently. I like the people to be able to run their own things on their own house at their own free will, and whatever, in how much ever capacity they want to, and own their data like in that way. And these HBC revolutions are really making it like getting us closer to that. So that's why, like, that's my interest. That's what drives me. So more content coming up for Latte Panda Mu. I have a lot of things to talk about, show, and actually do and make on these things. So not today's topic, but I just wanted to show that. So those are the stuff. It's good to know that there are so many more people that are also interested about SBCs and stuff. If you have any community, if you like the performance with less power, yeah, it's not really that less power. It can actually boost performance so much higher, especially in 100 part I was talking about. So it can go from 6 watts to 35 watts, right? It can ramp up really hard if you need for any specific purpose, disk IO or something. So it really almost never feels like it's lagging at something. Basically it punches way above its weight class, like it's um, super cheap, super cheap, CHIP kind of cheap. Uh, Intel actually had a banger. They just didn't maximize it well enough, or maybe they did. Many of the entire maker community is really excited about the N100 chip. Anyways, now we have the downloads. Let's get back into testing them. Let's see. Let me try. This should do it, right? Oh, this is not for uh, ARM64. So should I try? Is there any ARM64? I just see no. So there's no Geekbench that is for ARM64 in here. Interesting. Let's check out the oh wow. Is there a different edition? Did I download the wrong version or something? Was I supposed to download a different version? Because wait, it doesn't say. It doesn't say Android or ARM. Sorry, and ARM or x86. Oh yeah, it does say this here. In that case, oh well. So for Linux, we don't have any NPU benchmark. That's sad. Maybe this is our salvation. Olama 3.2. Okay. Olama 3.1. So let's go ahead and try this then. Right. Let's go. We are doing Olama. Let's try it out. Because apparently Geekbench is not supported on our platform. I should have known. I wonder how the other people do that then. Is this the paid version? Does Geekbench have a paid version where you have ARM for Linux? I don't need to dwell on this. I'll come back to it some other time. Let's go to Hugging Face. Never mind. I don't need to go to Hugging Face, I think. Do you think it will identify the NPU and actually utilize it properly, or do you think we might need to tinker with it? Because I don't think any of the models that are there, sorry, any of the models that I've seen there that were quantized to int 8. So which is why I was like not prioritizing it, because I don't think the half precision or full precision inferences would run well, because here's the thing, RK3588 is like they don't even put the precision full precision benchmark on their datasheet. This is just 6 stops int 8. So I'm assuming that not trying any model that is not any model trying any model that's not int 8 is gonna be severely bottlenecking. But that's what we are trying anyway, right? The NPU of this board. So just try one thing. I can do this. The while it's installing, I can show you. I think I did show you yesterday, but let's do that again. That is our K3588 datasheet. So this is the brief. The brief one is the one that you want to see. NPU. Let me zoom it in a little bit. You see, the NPU says 6 stops int 8. This is what we're talking about. So it does support int 4, like even more quantized, and int 16, this is which is the half precision, floating 16, which is also the half precision, like but different, you'll get different kind of results. B float is the one that is most of the, like basically the entire half precision world is going towards, or even the full precision world is full precision and half precision, instead of trying to divide themselves in between into full or half precision, they're all coming down to B float 16, because you get full precision like accuracy, but at half precision like compute advantages. So that's the sweet spot right there, all things considered. And the full precision is 32 bits, so there's that. If you, like, basically this is a Sisyphean task for the NPU. These ones are like, you leave quality on the table, here you leave performance on the table, and this is where you leave basically the power on the table. This one is basically the best of all worlds, B float 16. But if this can run B float 16, that's good. But other than that, int 8 is going to be, like, if we can run int 8, we will prefer to run int 8. That's the advertised sweet spot for this particular SoC. So basically it says that TF Lite should run, PyTorch, ONNX, and Android NN. Android NN doesn't matter here. I'm assuming here we will probably run models with ONNX or PyTorch. Right, let's put this aside and see if the installation was completed. Right, no NVIDIA AMD GPU detected. Olama will run in a CPU only mode. So basically it did not identify any kind of linear algebra device. So these are all basically from the model's perspective, from the platform's perspective, Olama or whatever the platform that you're running it on, from their perspective, they just need a matrix manipulation engine, linear algebra engine. What are you providing? So one benefit, that the reason NVIDIA is so like taking all the cake is because they kind of created the CUDA architecture, and that fueled this entire madness, which is why CUDA is in itself is a device name that everybody understands, right? And other than that, if not CUDA, then CPU. It's almost as if like this. So even many of the like previously all the AMD GPUs also had to pretend to have CUDA cores and processing, all these things. Then it got even more complicated and stuff. But those things were there. Now after TPUs, when Google was like building the TPUs, they were like, no, this has gone way too far. We need to generalize this. So, for example, the PyTorch XLA that generalizes this. So XLA is like cross linear algebra. X stands for cross, if I'm not mistaken. So basically, it's like general purpose linear algebra abstraction layer. So you can tell it to use a CPU, any GPU, any NPU, or any other thing, and it will use all of those things as the linear algebra solution. It will just hand it over to that, and it will have all the adapters it needs to make it presentable to those particular linear algebra engines. Now, the question is, if that handing over mechanism is not there, for example, if Olama is only looking for having AMD or NVIDIA GPU, like, do you have the GPU? If you don't have the GPU, then you don't have linear algebra machine. If it is that simplistic, then it might not be able to find out the NPU that this board has, because the concept of NPU is really new, and most of the people that are trying to run like local inferences, they are not trying to do that with NPU. So software will probably need to be updated to use that as well. But let's give it a try and see how the CPU performs, maybe whether any NPU we can see that pops up here, any benefit that we get from the NPUs, right? So let's learn Ulama. Serve. Okay. Okay, let's serve Ulama. Uh-oh. Ah, for some reason, it's not allowed. Maybe it's not allowed to be run as super user. Let me try to run um, as normal user. Oh well, it's not finding 4311 434, or maybe the server is already running. Maybe it, when we installed it, it started the server. Check that. Did we check whether it did start the server? Created Symlink Ulama service. Yep, it started the server. My bad. I apologize. Which is why the server is in use. All right, cool. Installation complete. Time to, sorry, Ulama is running. Okay, Ulama run Llama 3.21b, 1b parameter. So how big is this model name? Now model size. I haven't been using Olama and everything. So basically, I am out of this ecosystem for like over 3-4 months. I have been building Xplex in this time. So basically, I offloaded my entire firmware to something else, and I have been like working on a different headspace. So you have to help me out, and thanks for helping me out. By the way, I'll go ahead and run Olama run 3.2. How big is the model size, by the way? Do you have any idea? Oh, 1.3 GB. So that makes it 1B. Good. I'm gonna delete this. I don't think this is useful in any way. All of it. I think from the next time onwards, I should isolate my stream, the connection from my stream from my regular internet, so that the system that is streaming does not hog up the resources for other things, or the other way around. The other systems don't end up hogging the resources for the stream. The stream should be back up now. Hey, it is readable speed, right? I think even if it is CPU inference, I think it's doing all right. I am live streaming let's give it an somewhat limited prompt and see what it does. By the way, can you see it now? Is the stream lag has gone, or are you still facing lag? Let me know if it's still lagging, or let me know if I should increase the size, by the way, the font size. I think I should. I would just go ahead. There's no harm in that. Um, Let me try and find out profile preferences. Uh, where the hell is? Okay, yeah. Please use 16 pics. All right. This should be better. Yes, able to see. All right. So it gave an answer. It was pretty like decently lengthy. Like I was just trying to understand like whether it just says hi and sits down or something like that. But it was like it sounds like you are running some impressive tests on a custom built setup with an SBC. At its core, it's just affirming the prompt, and then live streaming that process can be both entertaining and educational for your viewers. Okay, that's just affirmation. Going ahead and greet your audience right now might help break the ice and create a more engaging experience for them. What's the plan behind this test run? Are you looking to compare performance, explore new music or audio format, or something else? All right. Should I ask something? Do you have anything? Much better. Yeah, yeah, it's actually usable, right? It's surprisingly usable. Do you have any question that or you want me to ask it? I would just go ahead and ask something, but if you have any question or more questions, just go ahead and like add them with question marks so that I know that you want to ask them, uh, want them be asked. I'll have to still type it in because I cannot copy paste from here to this because this is a screen capture, right? Right. I'm just testing the inference performance. This is 1 hour. Let's give it something open-ended. Hey, it's fast. It's fast. I cannot read that fast. It's that fast. I just want to see the NPU. NPU, we are not using the NPU, unfortunately. Right? I think this is the part where I'll have to tell you that, hey, we need to wait for the team to provide drivers and support for the NPU to be detected, and also Olama to basically be able to identify and use that. So until that point, this is still using CPU. This is not using NPU, right? Right. It's answering pretty like consistently. It's decent. It's not like given this is the 1B model, I'm not like expecting any kind of a reasoning skill or anything. But let's give it a reasoning, right? Give me a reasoning question. Something that would be this is BC. I shared the link above. Just if you shared a link, I didn't get it though. I'm sorry. Let me see if the links are being blocked for some reason. I don't see any link though. There is no link, nothing on hold either that I need to like clear up. So I don't have any link blocked. Maybe just don't post it as a link. See if that gets it through. Don't post it as a link. Just post it as a text, as in the dot something. Don't put the dot. Like put a space in between, and that would help. So want to see the NP shared a link above. Just look into it. Yeah, I don't see any link. Mm, right. Let me. Nope. I see look now, but I still don't see any link. I think YouTube is blocking out your links. I have the chat interface, the admin interface open. So if you post the link, I should be able to approve it or deny it. I no, don't intend to deny it. I'm just saying that if you post it, I should be able to find it. It just has slow mode on 10 seconds because a couple of times I got hit by bots which spams the message. So I have 10 seconds. 10 seconds is very reasonable slow mode because otherwise chances of getting attacked by bots is really high. Uh, so apart from that, I don't have any particular censorship or anything. So you should be able to post links. And if it shows me that somebody is trying to post link, do you approve? I would approve it. I don't just see it. That's the only thing, right? If possible, post the link as not as a link. Like take the link, put every dots instead of dots, put a space so that I know exactly what you're talking about. I can still it will be like posted as a normal text instead of as a link. It will not get detected as a link. Right. Let me ask it some kind of a reasoning question. Max speed. It uses USB PD. What voltage should I provide it? I'm basically trying to see how much it knows about things. All right. It took it a little while. It took it a while, but it has thought about it. It's now answering. It sounds like you're running some pretty demanding test on the SoC for the USB power delivery voltage. Typical range is between 10 volt and 20 volt. Huh? Okay, interesting. For anybody not like watching it after, it's hallucinating. Um, Depending on the specific device and its power requirements. However, most SBCs like yours tend to operate within a narrower range, usually around 12 volt to 12 volt or 14 volt. It's pulling numbers out of its behind, but um, thing is, thing is, it is true about 12 volt part. although it actually didn't reason it, it's just pulling some numbers out from here and there. Given that your SoC is using 2.5 watts at idle and up to 8 watts in maximum speed, it's likely that the voltage requirement is closer to 12 volt, providing that part is reasoning. That part is like, okay, you probably need lower voltage, but 12 volt is not a low enough voltage for 2.8 kind of power consumption. Anyways, there is no correlation. The entire reason for me asking this question is that there is no correlation between direct correlation in that way. There is some common sense correlation, but there is no actual technical correlation between the power usage and the voltage requirement. It can vary wildly. So there's that. Uh, Okay, all right. So I'm not expecting anything better than this from a 1 billion parameter model. So this is pretty good test for the time being, right? So I'm gonna stop it. Control T. Okay, right. We exited. Let's see. Search Ulama for Rockchip on Google. You will find how to use NPU in Rockchip. Awesome. So that's the part. Thank you for explaining that. Let me go ahead and do that. Ulama Rockchip NPU. Okay, I will play the videos after if I can't find any text document. Let me see this. Where did this go? Wait. Where did this go then? The text is too small. Right, I will, for the time being, for a little while, I'll remove myself from the screen so that we can see most of the page, right? All right. Were you asking me to go to any specific URL, or is there any specific one I should follow? Does Volama's website have anything? Um, let's check out the models first, or nope. Blog. Let's look at their blog if they have anything. Small and multimodal reviews, hallucination, tool support, Google Gemma. Llama 3 is not very censored. Good, I just find it. Can you do one thing? Can you, if you can, if possible, can you @developer, DEVLOPER, on Twitter to send me the link? That link in DuckDuckGo top search. Okay, let's go to DuckDuckGo. Olama Rockchip NPU. Is that it? I should search that? Just say yes, or should I add something else to this? Olama for Rockchip. Olama for Rockchip NPU. Let's go. Let me know if I should change the search term. Does Olama support acceleration? This is the first one, first link. Let's see. Let me change this thing. Okay, good. It's hard to read for me. Llama currently uses Llama CPP. Llama CPP does not appear to support any neural network accelerator at this point. This is March. Uh-oh. I have no idea what's happening here. Something is wrong with the SBC or the display connector. Let me remove the reset the connection back up again. What was happening? Rockchip has custom compiler which will parse either ONNX model or something else and then run it on top of NPU. Hey, thanks Akshar. Yeah, website is Tau Fnac. I will look into this again. Just at the entry of Akshar, and we lost our display for some reason again. So, all right, let me try and see whether I can bring some of the display back. All right. I'm not sure what heated up, maybe the board or something else, but I kind of lost the display. I'm gonna try and reset the board and get into the desktop all over again. So I'm pressing the reset button. Right. All right, now let me reset the HDMI capture as well so that it's capturing the device. All right, I think something has gone awry again. I am having to reset the connection back. So today we got a few things. Sorry. So we got the temps, which is really good. We saw the storage performances. I actually had SSDs to test. So let me try and reset the board back along with the connections. But just in case I don't get to, then we will call it a closure for today because we have been live for almost 1.5 hours. I was planning to go for the external SSD test as well. So I have the external SSD. I'll pull it out of this and was gonna test it with the M.2 port. So this is a good time for doing that as well. So let's try and do that. However, just in case if the display again does not work out for some reason, then we will call it a day and maybe come back next weekend again. And by that time, I'm hoping to ratify some of the other things, like for example, how to run the models, etc. And yeah, run those things. Today's focus was mostly on the benchmark, and we got most of the benchmarks done. Only thing that I'm missing out on is that basically an M.2, running an M.2 and a Ethernet port, basically IPv3. So I will run iPath3 and I will run the SSD either right now if it fixes, or I will do it after and screen record it and then upload it in the video. Just giving the context just in case something like disconnects and it goes away. So um, yeah, game streaming is much simpler than streaming this. All right, I'm going to disconnect this and disconnect. None of them are actually particularly hot, so I don't know why there should be the connection issues like that, the one that is happening. I'm going to just first try the least invasive approach of just, have you tried turning it off and back on again, which I did and which just worked. So we are back on track, boys. We are back on track. Let's go. Cool. Awesome. So I don't know whether Akshar has been here for a while. You can go back and check out the tests that we have run before, some of the things that we have had run. Now next up, let me try to add this. This is a NVMe adapter, USB 3.1, 3.2. So this should ideally give me about like 1 Gbps speed, gigabit per, sorry, so 1 gigabyte per second. I should get, like, this is 10 Gbps, gigabit per second connector, 3.2. So this is the max speed I should get. But I'm assuming if the specs, what I read, is correct, then this SBC's board will limit it to 500 Gbps, which will be half the speed, so which will be something around 500 megabytes per second. The read speed we will get, and the write speed as well, because it will also be bottleneck. So first we'll try with the USB interface, then I'll open it up and you like put in the M.2 board directly. It's lagging again. All right. Let me try and check my Ethernet. So this is a note to me for next up, like as in from the next streams, I would try to stream on a different connection than my normal regular internet connection, so that nothing that I'm downloading, like when I'm downloading a large model or something, it doesn't affect negatively my stream, right? For today, I think there might be a little bit of a lag. If that happens, please do let me know. It's good to know that, because then I'm aware how often does it happen. Don't let it pass, slide off because you think that I might get annoyed. I'm not. I actually appreciate that feedback. This is good. So I'm putting in the okay. Nope. All right, it detected the drive and it also opened up. I think the power off button got pressed. My bad. I should have been more careful about it. Let me reorganize this back again. Right. All right, cool. So now that we have this, let me try and run. Okay, let me run HDPalm again. Wrong keyboard, guys. Let me run. So now we have the HDO1 that is identified. So let's go to, I don't have to go anywhere, so HDPalm. Okay, never mind. It didn't remember the history. So hdparm test dev is sda1. Let's see how the read speed goes. This is half the speed that I was expecting. um Curious. I was actually expecting it to be higher. I was expecting it to be somewhere around 5 Gbps means. Okay, let's do this calculator, right? Calculator. bro bro, come over here. So 5,000 by 8 equals to 625, so around here. And this drive is perfectly capable of doing that because I just copied over everything that was in here on a different system over 3.2 USB 3.2, and it did 1 Gbps, like 1 gigabyte per second transfer. So this is perfectly capable of that. But the USB here is somewhat not being able to deliver on that speed. Let's see once more if there is a run to run variance. Let me keep it outside and pull this here. No, this is like the variance is very much within, it's not that different from one another. All right, now should I try the other port as well? Let's do that, right? Let's do that. Let's eject. Can I not eject it? Safely remove, yeah. All right, cool. Now I'm putting it on the other USB port. The other USB port actually is not detecting it at all for some reason. There seems to be some issue. I'm not seeing the blue, the light going on, and yeah, it's not picking up. I will try it back again, maybe later on if I see any challenges with this. But what I'm seeing is that only one of the USB device is actually picking up the device, like the blue light is on, back on again, if you can see. So only one of the USB port is actually detecting this. All right, so I have disconnected and connected it back again. Oh, sorry, not familiar with Marte's interface. So let's do it all over again once more, just to like connection disconnection, whether that matters, or like that basically the connection mating has any impact on this. It doesn't. It's basically exact same number. So I'm gonna stop there. I'm going to take a record of this, and just going to vim, wait, oh sorry, hdparm, I ran it on, so this is 950. It has the details about the SDS, so we will know what we are running it on. So the next one would be on NVMe, so we'll also know which one we run it on. So this we saved. Cool. All the run details are saved there. Now it's time for us to open this up, get the NVMe out, and put it on the board and turn it back on again. All right, let's take it out. This shouldn't be hard, although I do need a screwdriver. I will go get that. All right. So um, this might be hard to see, but this is Crucial's Gen 3 NVMe SSD. I'll probably show it on this one. So this is Crucial P3 Zen 3 SSD. P3 is the model and Zen 3 is the PCIe generation. I have it pre-applied with thermal solution, basically a heatsink, which is not a big deal of a heatsink, but this is more than fine enough for this thing. So I'm going to turn the board off, and yeah, I'm gonna do it the good boy way, right? I'm going to shut it down, and then apply this, add this to the NVMe port. Let me go and get my screwdriver. Right, that should be it. Just to be sure, like just to be safe, I'm going to take it off of its power, and I'm also going to take off the HDMI connector. All right, now just to verify if the stream is going well or not, I'm going to check the stream out. All right, Saraswat has dropped, I think. Never mind. Yeah, it was giving me so much of a trouble. He was hanging in there as best as he could. Anyways, so now let's put the NVMe drive in. Don't think we need to screw this thing in, but I'm going to screw it in anyway. All right, we have our NVMe in. Now it's time for us to put it back in again, and we will turn it on. So we have everything on. All right, we have it. Gentlemen, we got him. This is sick. Let's see terminal. Right. Let's see. Super user. All right. We have SBLK. Do we have NVMe? We have NVMe. Let's go. it did not detect any partition. It did not try to mount it. It detected partition, but it did not try to mount it. Can we try to mount it? Or maybe it couldn't mount it because it's NTFS. I'm just going to I'm just going to try and mount it. If this uh, MKFS NTFS is there, MKFS NTFS is there. So I'm if expecting fuse is there, NTFS is supported. So let's see LSL MNT. Is there anything there? Oh yeah, it has something. E. Okay, media. Nothing. Vicharak. Woof, whatever, dude. Let's make a directory inside of it, or let's just see what are all the directories have available here. Hmm. All right. Let's see. Mount it and run mount. Apparently, it did mount. Let us just check it. Yep, it did mount. So things are working just fine. However, I would like to like format this, or maybe not. I don't know. This is an ext. This is on NTFS, right? I would like to make it. What is the other like extfs or something? The Windows is file format. Sorry, the partition file system. Extfs, I think. I'll figure that out after. Let's just go ahead and run some tests. Mm-hmm. 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 This is more like it. All right. All right. We'll also go and see Chromium browser. Let it restore everything. Let it restore everything it had. I don't need Olama. These are not needed. By the way, for anybody who is watching now or later, the entire thing about how to make rock chip, like support for rock chip on NPU and Mali GPU, I will figure that part out and I will come back to it later. It's just not very comfortable to do it over a like display capture. I can't really like this is very difficult to diagnose. So I will do that, figure it out, and I'll share my findings afterwards. For the time being, I'll move on to running the NVMe write speed test. So let's try uh, with DD. Yeah. So basically, write from zero, dev zero to to an image at size of 1G. So instead of TMP, I'm going to write it at um, where have we mounted? Run mount. Yeah, this is good enough. Let's see. It should be pretty instant. 1G is nothing to it. It's taking awfully long for an NVMe. I am not sure if I'm doing something wrong. It should not take this long. 34 Mbps. Eee, Jesus. How does that make sense? Something is not right here. All right. I think I should write another time. Maybe off flag desync. I think this is the problematic bit. I'm I'm removing the flag and see. Let's see how does it do. No, it should be faster than this. This is way too slow for. How good is the heat management of the board? So this is the, if you like, I'll give you the rundown, but the earlier part of the stream, like you can seek back and see, it is sipping less than 2, or like around 2 watts, 2.5 watts at idle, and like at max, like the max power I could push it is at 1.6 amps at 5.1 volt. So that is around less than 8 watts, which is the basically the maximum amount of power that a board can take, which already limits it at a very like efficient, very like thermally limited core as the SoC. The temperature was going at 44, 43, 44. I ran sysbench and max throttle at 8 threads. It still did not cross 45 degrees, and it has this bit of a teeny tiny bit of a like a heat sink that is pre-applied from Vicharak's side. When it came in with that. I was very much like, I was not convinced that it's going to be sufficient, but now I'm pretty much convinced that even if nothing else, the heat spreader that is on the chip itself probably would be sufficient. I will run the cell LM sensors if that makes sense. Let's run sensors, and you will see the temperature. So basically, yeah, 41, 42 degrees is pretty much all across the board. Right now we are not pushing it anywhere, so it's 41, 42. And if I run sysbench, let's say sysbench all CPUs like threads 8, we're running all threads. Even then the temperature is actually not that. So again, the result was exactly this before as well. And so if we run sensors now, you can still see that the temperature is still not breaking 45 degrees. It's still 44 point something. I am not sure whether it's like the sensor LM sensor is not measuring it well, but I can touch it and the board is not hot. It's like I can touch it for days. Like it's not hot, it's not warm. Like if your tea is this hot, it would be like, okay, I need to reheat it. So it's not at all hot. This is really really good. Like, I'm pleasantly surprised. Like I was wrong yesterday in my stream. I was like, this does not seem sufficient. I'll have to remove it. I'll do the thermal testing and everything, and then I'll remove it and I'll apply my own thermal solution. But I don't think I will. I think I'm gonna just let it be. Whatever is in there is doing its job. It's doing its fine. I'm not gonna screw with that. So yeah, thermal is it's pretty good. The only challenge that I'm seeing is that the NVMe read speed is bonkers, as it should be, but the write speed is really bad. So if you see here, the read speed is good. I think I should just um, take this and save it as the run, or maybe I should run it once more. Let's just run it once more, right? Just to remove the variances. Let's do a test, and we will copy the result to our benchmark directory where we're saving all the data. I'll use all the data later on, so for the timing I'm just taking a snapshot of it. By the way, hi Manoj, welcome to the stream. Thanks for joining us. Shashwat, if you're watching, do you have any idea why we have such poor write speed? Um, oh wait. What's the time now? Okay, 10:07.txt. Right. So this time it came out a little lower than before. Let me do one thing. Let me cd2 run mount. Yeah, let's remove the images. Then all right. Now let's try the HD parm once more, because we know that HD parm actually basically goes down as disk gets taken up, disk size gets taken up. Okay, fast, but speed is going down, by the way. If you notice, 1500, 1400, 1200. Holy shit, why is that? Am I falling into some kind of trap? No, this is just run to run variance. Okay, maybe I should also like close the browser or something. It's not having enough IO. I don't know. Let's see. Give me 1500 once more. No, but I'm gonna go ahead and save this. Even though the first run was the highest, um, I think if we run it 5 times and it consistently gives lower result, I'm gonna take these ones as more practical result. So vim, what is it? Oh, sorry. Right, so there goes our NVMe tests. All right, so we have done all the power tests, like as in consumption tests. We have checked out the USB. One of the USB is not working for me. I'll need to do some further test on that. I think one of the things that is missing now still is iPerf, and for that I will need an Ethernet cable, and yeah, let's set out for iPerf. That is the only test that is missing for the time being. So let me grab onto uh, some Ethernet cable and test the Ethernet performance. I'll have to also set up the server on this computer as well, so that we can run the tests. I will mute myself for a bit It should not take me more than 2-3 minutes to gather around the equipments. Please hold on to it. All right, and I'm back. And that was fast because I just realized that I had some Cat 8 cables that I just um, unboxed. And these are for 25 gigs networking. Like, I am working on a 10 gig network setup on my for my home networking, and these are for that and with future proofing. So these should deliver, this should be more than sufficient for this 1 gig Ethernet connection test. So let's go ahead and put them, like actually add, connect them together. So I have, if we are able to see here, let me show this, turn this camera around and show that this dongle has an Ethernet port on this side. So I'll connect it there, and I'll connect it with this device's Ethernet port, and then we should be able to run the server on my this system and run the client from over there, or the other way around. It should be fine either way, but let's just go ahead and do that one step at a time. So first thing first, um, this is the crazy bit, a little bit flimsy shaky stuff. This is breaker space after all. This lives up to the name. Okay, we have the connection made. Let's see the other end. Let me, all right, on the other end also, all right, we have it connected. Let's see if we get a network connection over here. Wired connection 1, it has been able to establish a wired connection. Now I will have to disconnect its, basically I will turn off the Wi-Fi for a little bit. I will do that after. First let me enable my camera, and and Ethernet network disconnected. Why that is the case? Do you not want to get connected? I'm just diagnosing my um, host system's network connection. Why would it not want to connect with that SBC? It shows link speed 100,000 Mbps, which is GPS connection. Metered connection no. Wired connection 1. MAC address, clone address, MTU, IPv6, IPv4, automatic DHCP. It looks okay. There should not be any issue. In fact, from this side the connection is actually already accepted. I just need to see why on this end the connection is not working. How about we disconnect the, sorry, disable Wi-Fi and then see if that, uh-oh, okay, finally it was able to disable Wi-Fi, and the connection is still there. Wired connection 1, it's there, but it's disconnecting. I don't know what's happening. The wired connection is keeping on disconnecting. um hmm, this needs more diagnosis. Any idea, anybody, why this might be the case? If I'm doing something wrong, I should change my approach. So I'm trying to connect the two systems on a peer-to-peer mode. uh, so my this streaming system is the host and the SBC becomes the guest. I can see that it has detected the wired connection, Ethernet connection, and then it's disconnecting all the time. I don't know whether I should set this device as a master. How about this if I do it manually? Let me try and set this device, my host device, this one, as the master, as in it will have the gateway and everything else. IPv4, let's say, um, manual. I don't think that's gonna help here. They should be able to handshake and set up their IP address by themselves, and that does, like, this system works fine with any other system for that matter. For some reason this board is not capable of like establishing this connection. I am not sure why that is the case, but I think we'll have to then, along with the USB and USB CSI DSI links, and the PCI, like the FPC connectors. Those are the things. Along with that, we have also the Ethernet link that I need to take a second look at. The other things are mostly done. I do want to add a headphone, as in normal earphones, to the earphone plug and see if I am able to play something, like play YouTube video or something, and see whether I can get the audio out, as well as try to record audio and get the audio in. This does show the wired connection is there, right? So if I, okay, wait, I'm just gonna ignore that it is having challenges with wired connection. I'm going to run the iperf anyway and see how iperf does. So let's go Chromium iperf 3, server and client I need to run. So what's the, how do I run it? What the hell, dude? I'm disabling the cameras for the time being because I cannot see. uh, I can let it be, this one stay. So let's say installation is done. iperf s is server, and use the default port. Okay, don't think I need to mention any port. And the client is -c. All right, cool. And then I need to mention the port. So let's say I have iperf 3. Let's say this is the server. I just run it. It's listening. Oh wait, no. I can't. I have to run it as client. My bad. Let me run the host system with iperf, because I'll need the result on the guest system. So my host system has to be the server. Okay, iperf. I don't have iperf here, so let's go. All right. No. iperf 3. Is it iperf? No. Control C. iperf 3. Do we have iperf 3? iperf 3 is available. Okay, yes, let's go on Fedora. So let's start the server. iperf 3 server. It's running on port 5201. Okay, all right. Now I need to move on to this here. iperf client and IP address, right? Oh shit. Now I need to find out the IP address of the interface. Let me just try and figure it out from my base connection. Wired connection is showing disconnected again for some reason. Uh, it hasn't gotten any IP yet. Let me try and give this. What is link local only? Let's try link local only. Now it's connected. Or is it disconnected? What's happening? Okay, if it is link local only, does it get an IP? Let me try and figure it out from here. IPA, oh, IPA. So now I have the interfaces that are so loopback, there's wireless, there are virtual connections. That is that that's for virtualization, right? Virtualization bridge. So I'm gonna ignore that, and the ENP57 something, that is probably the one that we are working with here. We have 169, 254, 131, 120. Okay, let's park that. Let's see if this here I get IP A first. So here, Right, ETH 0, this is down. State up, that's the part, like it's state up, but for some reason there's no IP address, it's not resolving. Maybe I'm doing something wrong. Maybe I need to check what I'm doing wrong and then come back to it. Network disconnected. Okay, let's click connect, see if that does anything. If it's trying, it's an intermediate state. It has it like IPv6. It's unable to establish IPv4. I think that's the part where I need to go back and change it to DHCP. Hmm. It shows connected from this side, or from the host side. That's the reason I kind of don't want to change it. But I think we have to. Okay, IPv4 method automatic, IPv6. I am going ahead on a link. Oh, IPv6 is also automatic. How about we disable IPv6? Just IPv4, take it or forget it. Right? Connecting. Here. Noops. Let's go and see if we can, from the system settings, do something about the network to make it detect advanced network configuration. Hoping this is the one. Last use never. That's very promising. All right. IPv6 settings automatic. No, disable. Let's disable IPv6 for the time being. I don't want to make it try random things. Try to connect over IPv4 DHCP. Okay, let me disable this shoulder cam as well. All right, I think we gotta close this up. There seems to be some kind of issue. If I try and connect automatically with priority minus, something like this might be of an issue. I'm not sure exactly what's happening in here. Right? Okay, I will reset back the IPv6 settings to automatic DHCP only, the way it was. Alright, I will save it back and let it be. If we can resolve the network connection disconnection issue, we will make a different video about that later on. For the time being, we were unable to connect to a wired connection, so I'll let it be. I'll let that be the result of that check. All right, quick catch up on the chat if there is anybody that is watching here right now. um, Right. I don't think so anybody else is watching right now, so that is fine. We will wrap this up and call it a day. So to wrap up, the power management, thermal management, the software, and everything else went pretty smoothly, like worked pretty well. I'm fairly very happy with this. Most of the other peripherals were also working very well. A couple of hiccups I have faced is that one of the USB port is not delivering power or not working entirely. I'm not certain. I'll have to do more checks on that. The other USB port is working well, even though, yeah, the speed seems to be limited or lower than it should be, than Zen 3 speed, like the 5 Gbps speed. It's lower than that. So, okay. Aside from it, um, I have not been able to test the CSI and DSI or the combo ports, the MIPI connectors, all of them, because I don't have any connector that is this mezzanine connector. This seems like a Hiroshi connector, Hiroshi mezzanine board connector, which I don't have. Oh wait, let me turn on the face cam. And then, yeah. So I don't have the mezzanine connectors for those MIPI combo ports. Uh, Also, I don't have the connectors or the FPC the um, for the breakout for PCIe and the SATA PCIe combo ports that is on the board as well. So there are three PCIe lanes basically. Two of them are together in one connector, APC connector. But I think from the pinout, what I see, there are ref clock for, like, there are two sets of ref clocks and everything else. So you can actually run two different devices without needing to make them go through a switch or anything, PCIe switch. So basically, you can actually run three distinct PCIe device apart from the ones that are, like, apart from the NVMe that you can connect it to on the board itself. And the NVMe does give good read speed. The write speed is not that. Good night. Um, the write speed is not up to the mark. It's 30 Mbps or something. So that is something. By the way, we should try and uh, run that test all over again, just to see that it was not a mistake. So we have everything correct. Yep, let's go. So I'm just going to run it once more, just so that I know, like, I stored this data. So this is giving me 35 Mbps speed, write speed, which is terrible for some reason, as in, and it should not be that slow, or a write speed that slow should not be the case. I don't know what's going on. Anyways, um, the Ethernet port I did not get to test because it's not failing to connect. And yeah, it comes back again at 33 Mbps. I'm just going to um, put it down. So I'm gonna do one more test. I'm gonna do them both, like one with sync, without sync. So let's do both, and see the, basically save the results. So that the caching or buffering did not really got to be the deciding factor here. That's the reason. Anyways, so I digress. The only thing that I want to try out is a headphone connector. I guess I'm gonna play an YouTube video and see if that's working. So just give me a moment to hold on to my headphones, right? And okay, I have the result here. So let me save this first. 9:36. All right. All right, we have the right test saved. Now let's go ahead and connect the headphone connector. I have it connected now. Um, let's go ahead and play something from YouTube. I don't know whether you should be able to hear anything. I should be able to hear. Um, yeah. So right. Let's just play back this video, the stream that we are currently in, and I can hear that. Oh, did I clicked on the video to pause it. I can hear it. I don't know how can I make you guys hear it. Um, I'm holding my headphones outputs as close to my microphone as possible. This should give some amount of um, audio bleed into the actual audio to the stream. That's all I got for you for now. I will figure out how else I could have channeled this audio in. I mean, I can take this audio in and put a like TRS jack and run it as a audio in to this device. That should work, but I'm not going to. The audio is working. There's no challenges there. I'm going to close this and try to see if there's any recording webcamoid. Okay, I don't think I have any webcam here, so it shouldn't be able to record anything. I don't think it will even run. Voice recorder. All right, let's try and see if we have anything else. No, I don't. All right, cool. So with all that said and done, I'm going to take the risk of running apt-get upgrade because I haven't run upgrade yet. I needed to run all the tests before I run upgrade. So now that I have done all the tests that I possibly could for the time being, I'm going to go ahead and run upgrade. And see if that breaks anything or not. All right, meanwhile, I'm also going to go ahead and disconnect the Ethernet because it is keeping on trying to connect and failing. So that's not helpful. Right. I think there is one way to test out the audio is from the settings itself, where we'll find sound. By the way, let's get the face cam up again. Right. Something wrong with the face cam. Never mind, I'm gonna turn it off, and we're at the kind of at the end of the stream, so doesn't really matter as much. Let's just go ahead and see um, output volume. Input, okay, internal microphone instead of that, headset microphone. All right, can we test it? Test speaker, the speaker test, yeah, that part is working, but the input we need to, let's, how do we try out? There's no application. Okay, maybe we cannot test the input right now, so we will also put that on our bucket list for trying out later. With all that said and done, it has rebooted up again, and I'm going to disable this as well, and go back to our terminal. What is this? Don't send. Right, and I'm going to reboot the system, and if it successfully reboots after being apt upgrade, then that's a pretty good thing, because many of the boards don't really support that. For example, some of the RISC V boards particularly forbid you from running apt upgrade. So if we are able to upgrade the board, that's really good. That means we can live up to date with the other software channels. And yeah, later on I will try to do a distro upgrade as well. Maybe I'll do that on a next stream, as in come back for the next stream on the next Sunday, same time, which is 8 p.m. Indian Standard Time, which should be something around 2:30 UTC or 2:30 GMT. PM. Right. So if we can reboot it and the system boots up all well and good, then that concludes today's stream. Thanks everyone for joining. Thanks everyone for pushing me harder to just like do more than what we set out to. And we also run the Olama. Basically, we run Llama 1B model, and it gave pretty good result. That's kind of the highlight, apart from all the other benchmarks we tried to run. That kind of the highlight that came out. Other than that, we have the highlights that are in here. So these are the data that I have, and these are the data that I will put it I'll use this data to publish the video that we will work on afterwards. All right, cheers. Hey, we are back in desktop. I am going to not relaunch this application and don't send it. Okay, we are going to officially now close down the stream. Thank you all for being part of it. Thanks for watching. See you again next time, next weekend, Sunday, 8 p.m. IST. Cheers.